Hi everyone, very happy to be here today with you. I will start this introduction by asking you some questions. The first is, who knows what a smart contract is? Can you raise your hand if you know what it is? 1, 2 people, okay. And who know what Ethereum is? Okay, more people, okay. So, this introduction will be to the XRPL EVM Sidechain, and why I ask you those questions. It's mostly because the way you will be developing on this blockchain is very close to the way you will develop on Ethereum. And so there is some concept that came with Ethereum that aren't on the XRPL, so specifically smart contracts. And so the way you will develop with this blockchain is very different from what you've made yesterday. So it won't be as easy. Mostly because you will need to write your own logic on the chain, but it allows you to do way more stuff. So, first thing first, we will talking about the XRPL EVM sidechain. We will first define what is a sidechain. Who in the room know kindish what is a sidechain? What is a layer 2? Okay, so a sidechain is an independent blockchain. So you can see it as another chain that runs and lives outside of the XRPL, and this chain has its own consensus and its own node, right? So it's kind of like another blockchain that lives by its own. It is a blockchain that is connecting to another chain through a bridge or a peg mechanism. So what's a bridge? A bridge is most of the time another blockchain that allows you to send message from one chain to another. And in the case of the sidechain, basically it allows you to send some message from the main chain to the other chain. And so you can build like some cross-chain application. If you have any question during the presentation, please raise your hands. Those are kind of advanced concepts. So yeah, if you have any question, please feel free to ask. And so the sidechain lives by itself. It allows you basically to send information from the main chain to the sidechain through a bridge, and the transaction on the sidechain are not visible from the main chain. So it's mostly a chain that is there, that is by its own, and that's connected to another chain. And we call it the sidechain and not a layer 2 because the state of the sidechain is living by its own, and the main chain doesn't have any information about the state of this other chain. On the graphs there, you can see basically the main idea. So you have this XRPL mainnet, which is the chain you developed on yesterday. Yeah. So there is some times. So let's say you want to send a message at time +0 on the sidechain. Because you need to get through the bridge and so on, you will maybe have it at like time +3 or time +5. So there is like a discrepancy between the blocks. So it won't be instant. And so this is like this is what mostly look like with XRPL. So you have the mainnet, which is the chain that you developed on yesterday, and then you have the sidechain, which is there, which is an EVM chain that is bridged through Axelar. You will learn more about Axelar in the afternoon. And so this is a chain that only have one sidechain, but you could also imagine that you want to build your blockchain for your own purposes and put it as a sidechain, and so you could have one chain that has many bridges. And if you look at the ecosystem today of blockchains, most of the blockchains looks like this, because when you integrate a bridge, then you kind of become a sidechain of the other chain. And so as all the chains are kind of interconnected through bridges, you get this kind of ish shim. Any question? Yeah? So the thing is that you consider the main chain safe. So this chain is safe, and the side chain won't be considered safe if the bridge is not safe. So the trust assumption is made on the bridge, and so you need to have a secure bridge basically to have your safetiness on the sidechain, if it makes sense. So what's the EVM? The EVM stands for Ethereum Virtual Machine, and it's, as it says, the virtual machine, similar to what you might know in your VPS. So it's mostly an engine of Ethereum, and EVM compatible chain, and this is what's basically run your smart contracts. It runs smart contracts in a universal language, so there is 2 or 3 languages, but the most known one and the standard one is Solidity. And basically this ensures that on all the EVM chains you have the same behavior for the same code. I will add some edge cases there because there is some EVM that are not always 100% compatible to the Ethereum Virtual Machine at very, very low level, so at the opcode level. But most of the time, when you will writing a smart contract on Ethereum, you could deploy it on other EVM chain. And it's mostly the foundation of blockchain interoperability, because most of the blockchain have adopted this standard and this language. You as a developer can easily develop an app on the XRPL EVM and then go target user on other chains. And basically it makes it very easy for all the tooling that come with this language, tooling that is testing frameworks, indexer and stuff like this. You can basically very easily plug and play those from your app, from a chain to another chain. So we talked about what's the EVM, but we didn't define what a smart contract is. And this is, I think, the most interesting concept in what we'll see today, because it will be the new way you will interact with a blockchain. So smart contracts, it's mostly a program. So it's programmable rules on the blockchain. It's code that is executed when it's triggered by a transaction. So it's a piece of code that lives on the blockchain. And when you want to interact with it, basically you will send the transaction to this, calling a function, and with some arguments, and then we'll execute some code. And you can build a lot of stuff with it. It could be decentralized finance, it could be whatever you want, because you have a full Turing complete language, which make it very, very interesting. It is trustless and transparent. So the rules of those smart contracts, the program itself is executed by the nodes of the chain, which means that there is no intermediaries needed. So when you are using a smart contract, basically you are running a piece of code on the number of nodes that there is in the chain. And so you are sure that the rules are enforced by the chain. And basically this is what powering dApps. So dApps stands for decentralized application. And this is the core engine of all this Web3 idea. Basically, it allows you to create tokens, DeFi, NFTs, and more and more. So it's very different from what you've seen yesterday, in a way that yesterday all those primitives, such as tokens, NFTs, and so on, was at the protocol level. So it was the root of the XRPL. Here there is no rules for NFTs or tokens. There is some standards at the solidity level, but there is no standard at the protocol level. And so you can create your very own token. If you need some very custom logic, you can add this custom logic. And mostly a smart contract is three main components. So this is more from a technical point of view. You have its address, which is very similar to an address on a computer. So this is where the smart contract is located. You have its ABI, same thing, very similar to what you could find on a standard computer. Which stands for application binary interface, and this is what's allow you to interact with it. So it's defined the different function method of your smart contract, and its state, which is the state it has on the blockchain. Any question there on the smart contract part? Yeah. So if you take a blockchain node, there is a lot of stuff that's going on there. You have the consensus, you have the storage, and you have the execution layer. The execution layer is the EVM. So you have you can see it as like a container that's plugged on the client, and then you have an interface that basically allows you to call the consensus, call the storage, and whatever. And so what happens is that you send a transaction, it gets into a block, and before it's getting into a block, it's executed on all the client. All the client agrees on the result of this code, and then it's in the block. And so you run the stuff on the EVM, and then basically, let's say you make a syscall to make it very easy. You make a syscall to use storage, and then the storage basically stores this into the trees and so on. Any other questions? Okay. So this is I would say, lightweight theory on smart contracts. And how it's coded, basically you have this programming language called Solidity, and smart contract programming is very close to object-oriented programming. The way you need to see it is that a smart contract is a class, so it's an object by itself, and you define method and functions similar to what you might do when you are doing OOP. So it's very similar to a class. If you get this abstraction layer of, okay, my smart contract is a class, then it is very easy to get starting developing on it. And because it's very close to OOP, you add all this idea of inheriting, expanding, and so on of your smart contracts. which make it very easy to build complex dApps because you can basically use the pre-existing standard and then inherit from them and create composability inside the smart contract you're building. Solidity itself has a syntax that is close to, I would say, C# and Java, kindish. And it's, I would say, a fairly well-designed language for smart contracts. The most hard thing to get about it is that basically when you are trading a token, it's not a token itself. It doesn't live as a token, it's just a mapping of a balance to an address. So there is no material as token as you might have on XRPL. It's only like a mapping. It does live on the state of the chain, and so because you have this balance sheet, you can then say that you trade tokens. So the sidechain itself, so we have seen what the EVM is, we have seen what smart contract is, and now let's go into the chain itself. So it's built with Cosmos SDK and Ethermint. So Cosmos SDK is basically, Cosmos is a blockchain that allows you to build other blockchains. And to do so, you have some frameworks and stuff like this. And so the framework used for the EVM is called Cosmos EVM. And it's the piece of code that basically allows you to run the EVM. The consensus is proof of authority. So it's not very similar as what we have on XRPL mainnet. The way it differs is that there is an elections round. So you have a set of trusted validators. And every block, there is one of those validators that is elected and that propose a block. The way it differs from the XRPL mainnet is that the consensus on XRPL mainnet is from association. So all the trusted validators will talk to each other to create a block. But here there is only one that will create a block and the other will agree on the validity of this block. The block time is 4 seconds, so it's very similar to the block time on XRPL. It's kind of the same. And you have also instant finality. So when your transaction is on a block, it's final, and so there is no reorgs possible. And because it's built using Cosmos EVM, you have support for Cosmos IBC, so this is very, very advanced concept. But Cosmos IBC is mostly this idea of having a framework for interoperability and allows you to talk. And so IBC is this idea that you can talk from a chain to another with a specific communication framework. And it has been developed by Cosmos. And so because it has been developed by Cosmos, it's part of that framework, and so you have support for that. So why this is interesting? It's interesting because you have customization through the EVM. You can pick and choose an XRPL feature. So if you want to do, I don't know, escrows, then you can use escrow on the XRPL mainnet and then add composability and programmability through the sidechain. Because it's programmable, it allows you to do control. So as Luc said yesterday, there is a lot of institutions that can't be onboarded on chain because they don't want to trade with everybody. And so having these solidity layers allow you also to implement those control features and kind of those permission parallel network. And last but not least is that this chain uses XRP as a gas fee. And XRP is the third biggest crypto asset. And so it's a very liquid asset, which makes it very nice if you want to do DeFi application. It's not that often that you can basically start creating yield opportunities and stuff like this on the $200 billion assets. So there is a big market opportunity there. And the EVM sidechain is one of the tools that you have to basically create those applications. Yeah. So I wasn't part of the development team, but I think they chose 4 seconds because it was the same block time as the mainnet. So they wanted to have like 2 chains that produce block relatively at the same pace. You can always go faster and basically create like a layer or 2 on top of the sidechain and then have like, I don't know, 200K TPS on top of it and then we put the state of it. But to have like, if you need 200K TPS, that's a very good problem to have. Like you need to have a very lot of users and basically you have a worldwide company. But currently, like 4 seconds, I never see the chain getting down of like transaction being awaited. So as user experience, you don't really feel it. I would say it's more like if you have technical, if you are working on, I don't know, gaming stuff and you want to put a lot of stuff on chain, then let's go deeper into the blockchain stuff and like create a layer 2 on top of this chain. That's allow you to have way faster TPS and then re-put the state on the other chain. So there is a company doing that. I think it's called B3 Labs. And what they have done in that, they have used a stack called Arbitrum Nitro, which is a layer 2 framework. And basically there is these chains that live on top of the sidechain. And basically it's allow you to get like 50K TPS or so, whatever. And then it basically store the state inside the sidechain. And so you get way more transaction that way. Other questions? Yeah. No. So this is a sidechain, not a layer 2, so there is no settlement on the main chain. Difference between sidechain and layer 2 to make it easy is that on the sidechain there is no settlement of the state. You just have the trusted bridge between the two chains. So as of today, I would say every chain is a sidechain of another chain. And layer 2, you settle the state on the layer 1. Yeah. I mean, because Axelar allow you to bridge from XRP to Ethereum, then you might argue that Ethereum and XRP are both sidechain or whatever. Like, sidechain is a concept that has been lived and used in 2017, 2020, and then it has been kind of replaced by layer 2. So there is not that much work done on sidechain now. Other questions? Yeah. Benefits is that you have your whole security assumption. So a layer 2, your assumption of security is the one of the layer 1, and you will lose also finality. Settlement and finality is a very important metric if you want to build a chain. And so on the layer 2, the finality will be the time that your transaction is included into a block from the layer 2, then verified into the layer 1, and then this verification transaction final on the layer 1. And so if you take, for example, Starknet or another layer 2, they push the state every 8 hours and so you wait 8 hours to be pushed onto Ethereum, and then you need to wait 12 minutes for the consensus round to be final. So the worst case scenario is that your finality is 8 hours and 12 minutes. You might argue that we don't care because it's never supposed to roll back, but from a theoretical point of view, you have this finality that is way too long. So this chain is called Axelar. It's, I don't know, it's a company, but I don't know the information behind it. It's a chain that is built specifically to do those kind of stuff, so cross-chain messaging. So why we build blockchain for blockchains? It's mostly because as you don't know what's going on outside the state of this own blockchain, the only way to have like trust assumption strong enough is basically to have a blockchain as a middleman, and so this serves as a middleman. And I don't know if Matisse is there, but you will have like presentation of Axelar this afternoon. And so what to remember is that this chain supports Solidity smart contracts, which allows you to run Ethereum native dApp seamlessly. It uses XRP as a gas token, so which means that there is utility and demand tied directly to XRP. So if your app use a lot of XRP, then there is demand for XRP, the price goes up and so on. And the bridge is managed through Axelar. On the QR code there, this is the website of the EVM, where you will be able to find most of the doc. And I think that's it. Yeah, that's it. So I will just put the QR code there. Let me check the time. I think we can take 10-minute break for you to digest the information, and then we'll back at 11:15 for the workshops. Yeah. So the gas token is the token that is required to pay gas fees. So gas fees is this concept that because you are putting information on servers, you don't want to, like, as the guy who owns the server, I don't want it to be free. And so I will require you to pay a fee. And because here in the case of the EVM there is computation, the price you will pay for a transaction is tied to the computation that it will required. And so it's called gas as stuff you put into your engine and your car. And so you pay those fees in XRP. No, I don't know, it's like some cents, I would assume. Yeah. On the mainnet, they are burnt. On the sidechain, I don't think they are burnt. From what I've talked with the guy behind it, I think they are just collecting it because they want to do like some grants program or ecosystem stuff. But for the moment, you can consider it that they are burnt. There is, as it's POA, there is no incentive. So in in Ethereum, those fees will go to the validators. Here, there is no incentive, so the validators don't touch any XRP for validating this chain. Any last question? Okay, cool. So let's take 10-minute breaks. If you have any question during the breaks, please come see me, and then we will start the workshop. Thanks.